Hi, everyone. Welcome to the third Industrial Virtual Career Fair. I'm the moderator. My name is Yasu, and today we have four wonderful speakers from different organizations, and this is our tentative schedule. We'll have Ming Li, a research scientist at Amazon, who's the first speaker, and followed by Subho Majumdar, who's a senior inventive scientist, the data science and AI research group at AT&T Labs. And our third speaker will be Ted Listig, senior director of corporate biostatistics at Medtronic. And our last speaker, but not least, is Bonnie Ghosh Dastida, senior statistician and head at RAND Statistics Group. Welcome all to attend. And we have, at the end, we have a Q&A session from the audience and speakers. And this event is hosted by, we have two hosts, James Rosenberg and Glenn Johnson. As I said, there will be a Q&A session at the very end. That will be the chances for our attendees to ask questions. And here's a simple guidelines of how you raise questions to our speakers. There will be a Q&A button icon at the bottom of the Zoom window. And you can type in your question, and I will present your question to the speaker at the very end. And here are several other usage for how you use the Zoom to complete your complete the session. And here I want to remind you that there will be an invitation to evaluate the session at the very end when the session is over. We're looking forward to your feedback to this event. And also the link, the recordings of the session as well as the slides will be available on the NISS website within a day or so. So I think that's all my time for the opening remarks. And Ming will continue with his presentation. I'll pass it over to Ming.
Thank you, Yasu.
And Ming.
Can you see my screen well?
Yes.
Okay, great.
Do you mind full screen? Making
yes,
it full screen.
It's
Is it already?
Full screen.
Okay,
yeah.
Right. You can continue.
Thanks for having me here today, and I'm going to kind of briefly introduce the data science career from a statistician point of view. By training, I am a statistician, but recently I'm pretty much working on data science and research science area at a tech company. So we all know what the difference between science and engineering, like physics and electrical engineering. Physics is very fundamental principles, which will have little impact on people's daily life, but engineering is actually utilize all those principles we know from science to fundamentally change people's day-to-day life. Like electrons is the fundamental discovery in physics, but iPhone and smartphones are one of the applications of how we can use the science to change people's life. Statistics, and probably you are agree that most of the statistics department is in a school of science. And do we have a statistical engineering department? Actually not, because statistics is so fundamental, so it has been used across all different kind of areas that people use statistics to solve their problems. And the data science the recent kind of development is primarily focused on the statistical engineering piece. That is, we already have all the principles and theories about the statistics, but how can we apply them to fundamentally change the business operations and people's life? For example, now we have so many data available and the software is so powerful to enable us to deal with all those big data. So in my kind of opinions, data science is actually an engineering area. It is trying to use statistics and other areas theory developed to solve a specific problem. So at the end of the day, it is the engineering concepts. We have to solve something that we can apply it to either a organization to reduce cost, increase frequency, or improve revenue, as well as improve people's daily working experience. So this is, in my opinion, that data science is actually an engineering area. And for students and practitioners of graduated from statistics department, we usually have the very good at the science piece, but not that much as the engineering piece. That is one of the areas that we're going to cover briefly and how we can prepare statisticians, especially graduate students, to be a better data scientist candidate. So for statistician, we are all very familiar with what we do. Like we relatively focus on modeling, it's kind of science flavor. We really bring the model, bring the data to the model. Data is relatively small in size and clean in text file format. So all the data can be fed into the memory of the computer. Usually structured data, numerical data, categorical data. Statistician is usually isolated from the production system. The production system is basically the IT infrastructure where everything is running on top of that. For data scientists, it is actually mainly focused on the business problem result. That's the engineering aspect. We usually bring model to the data because it's so huge, so we usually bring the model to the data. I need to work with very messy data in large amount of data in all different kind of formats. It's both structured and unstructured data. Data scientists are usually embedded in the production system. So once the model is developed, people would like to kind of like embed this model into the production environment such that it can run in real time to provide value. So based on the where the data scientist is part of, there are kind of like two types of data science career. The first one is what I call a generalist. Basically, it's kind of like all different kind of business problems. It's very general. So it can be one day in an HR department and a second day it can be in a marketing department. There are also a specialist. For specialist, it has one special area to focus on, like a natural language understanding, voice, and chatbots. So all those are very specialized skill. And today, I'm only focused on the generalist career track in this talk. So for generalist, a very strong business problem formulation skills, data pre-processing skills, and statistical machine learning methods, deep learning applications, in a general model building process. Those are very important pieces to have. We all know those like three pillars in the skills for a data scientist. Like for example, modeling knowledge. For statisticians, modeling knowledge is kind of like a given. But we have to implement the model using a scripting language, either Python or R. That's what we are good at it. There's another angle is a production environment knowledge and programming. That is, programming is basically how the model will be implemented in the production environment, like a SQL to pull the data, and currently the big data platform like a Spark and all those kind of programming knowledge in production system knowledge. Sometimes not every statistician is familiar. And another area is very similar to our consultant, statistician consultant area. We have to have a very strong business knowledge and we have to have the problem solving skill. Fortunately, the production system knowledge and programming, that used to be a big barrier for statisticians to enter the data science career. but the recent trend of cloud-based solution actually lower the bar, lower the barrier for statisticians dramatically to into this area. Because in the cloud, everything is getting much easier than before, including developing model and implement in the production environment. So if you are good at all three areas, you become like a full stack data scientist. That's actually, in an industry setting in tech companies, especially startup companies, people want to have this full tech data scientist because once they get one full stack data scientist, it's become one data scientist plus one software developer and plus one business analyst. So that's the ideal situation. There are two types of data science team. There's embedded with business team. As I mentioned, there could be a data scientist in a HR team, and data scientist in marketing, and data scientist in supply chain. There are also a core machine learning team, so that's actually a centralized team which has been has a lot of research and science involved. So this is depends on what kind of interest you may have. In each tech companies, there are both type of teams. One of the key features for tech companies is data scientists that are working closely with software developers. That is oftentimes data scientists, data engineer, and software developers, they're all in the same team to ensure a true collaboration with business teams. So once the model has been developed, it can be easily embedded in the production environment such that it can be run in real time to provide a seamless kind of transition from research and explore to production. So now I'm going to focus on basically from a statistics department point of view, from education, what might be a career path, and also the tasks and responsibility. That's kind of from my like more than 10 years kind of industrial experience that I kind of more or less summarize the difference. But with the education from bachelor's, master's, and PhD in statistics, as well as the potential career path. I call all those a data science family career. So I'm using the actual title from, those are actual titles in Amazon, actually. They are all deal with data science in a certain way, as well as the how we actually see the match. Like for example, there are business analysts and business intelligence engineer, data scientist, research scientist, and applied scientist. People with studies background can work in any one of those categories depending on the education level as well as the interest, but usually for business analyst, it will require a pretty strong business insight, as well as writing report and doing some analysis. So if you have a bachelor's degree in statistics, I think business analyst and business intelligence engineer are actually great fit for the education background. If you have a master's degree in statistics and then the choice are actually broader, you can work on business analyst, business intelligence engineer, but you can also work on a data scientist career as well. In data engineering, which require a lot of data pipeline and SQL, so it's not an ideal career for people with statistical background, but some people, if they're interested in, they can still work on it. If you have a PhD in statistics, and then you can work on kind of data scientist and research scientist and applied scientist. And research and applied scientist is actually more appropriate because it's involved more modeling. And you may wonder, what are the difference, a fine difference between all those careers for and what are the requirements. So in the last column, actually, I listed the relative separation about what are the day-to-day tasks and what are the requirements to be successful in each different career paths. Like for example, if you are a PhD in statistics, you already have a very strong modeling background. And for research scientists in Amazon, actually there's not much requirement in actually writing a production level code. But if you are both good at modeling and programming, and then you're a great candidate for applied scientist. Data scientist is actually primarily, in my opinion, in Amazon, because different companies have different definition of data scientist. It is ideal for master graduate with a couple years experience. So it's like a combination of modeling, data pipeline and dashboard and business solutions. So, but of course, anyone who are good at programming algorithm, they can be a very successful software developers. And so those are the tech career paths, some of the tech career paths in Amazon. And the good thing is each career path has its own promotion cycle. So if you are a bachelor's degree with statistics and you started with a business analyst and you do really good job about that, you do not need to have a master degree to get promoted. So if you are doing really good, you can get a senior business analyst or principal business analyst. So there are actually career paths for each there's promotion cycles for each career path. So depending on your interest, education level, and those are all potential careers that people with statistics backgrounds can working on. So in Amazon, if you are looking for jobs and pay attention to those career job titles, and oftentimes you will have some good understanding about what they are looking for. All right, I think my time is pretty much up. So that's actually good timing. So thank you.
Thank you, Ming. I enjoyed your presentation. And our next speaker would be Dr. Subho Majumdar. Subho, you can get your slides ready.
Okay.
And Subho, Dr. Majumdar is a senior inventive scientist at Data Science and AI Research Group at AT&T Lab. His research topics include viewership and network modeling at scale, data visualization, and the social aspects of data science. I think you can begin.
All right, so just to make sure the slide sharing is fine.
Yes.
All right, so as introduced me, I work as a senior inventive scientist in AT&T Labs, specifically the data science and AI research arm of the labs. And actually, the way Ming structured his talk, I really appreciate that, because that sort of gives a broad overview of how data science happens in industry and what are the different steps. And that kind of gives a good platform for me to build up on using like specific use cases, what's the case in our organization, and specifically how it is to work in a research environment. What does research mean in an industry setup? That sort of gives a good idea to begin with. So AT&T Labs Research, we are, in one word, we are the research wing of AT&T, which, as a lot of you might know, is a very big organization. It has a lot of different parts. The legacy AT&T, which is mostly the mobility cell phone business, think 4G, LTE, 5G. That part, there is AT&T TV, which was acquired by DirecTV, sorry, which is the rebranding of DirecTV that was acquired by AT&T a few years ago. There is Xandr, which is the advertising arm of the company that focuses on digital advertising, which means internet, TV, advertising over all these platforms, linear and addressable ads. So personalized as well as general advertising. And finally, Warner Media, which is the most recent arm of our company. That includes media channels like CNN, HBO, Warner Brothers, so media production companies and TV channels. And the way Labs works is to sort of work in conjunction with each of these parts, with teams from each of the parts of the whole company in certain projects, which are sort of like non-standard data science problems. So as Ming mentioned, there are these business workflows that work with certain goals and objectives and build up on concepts that are already there. You know that what you want to do, and you sort of build out certain production quality models. What we do is that we work with our clients, which are essentially internal teams from each of these branches of the whole company. And we work with them on interesting problems that they think are important to the business and that they think could give the business a competitive advantage. So we sort of build out POCs based on those concepts. And the challenge here is that even though we are building out POCs, because of the scale and complexity of the data, we have to make sure that those POCs are scalable. It's not that you just apply a shiny new method from the most recent statistical literature, the most recent machine learning literature, and that's it, that's where you stop. You need to make sure that that method can scale up to something useful. That method can scale up to something production quality from which some kind of tangible quality can be derived. So that's sort of an overview of the AT&T Labs research, and there are multiple arms of AT&T Labs, one of which is the data science and AI research, in which I am there. There are others like network research, who work in 5G build-outs and things like that. And a little bit of history. A lot of you might have heard of AT&T Bell Labs. So AT&T Labs Research is a direct descendant of the Bell Labs. That was rebranded a couple of decades ago, I think. And actually, we do have, our data science department has a long history of statistics. Schubert was there, Dodgen Romig was there, and well-known statisticians like Tukey, Ganadeshikan, Mallows, everybody were in the erstwhile Bell Labs. A little bit of the current history. This is actually, the labs is actually the birthplace of the R language. Specifically, it was known as S when the first version of the language released, and then it got became open sourced and became known as R. And finally, our team has actually won the Netflix prize. So Chris Walensky, who is the head of my organization now, who is the head of the data science and AI research now, him and a couple of his colleagues in AT&T collaborated with a bunch of people from outside, and that team got like the top scoring model in the Netflix competition. Going into a little bit detail into whatever we do currently, some of the projects that we are involved in, some of these I am involved in, and I'll go into a little bit of detail into one of those projects, just to give you an idea that how things happen. The things we work on are in these areas. Firstly, customer experience modeling, which is that think TV shows, think different types of content, how customers view that, which customers like, what type of content, profiling and segmenting those kind of customers and trying to extract business values from these types of customer segments. Next is machine learning based media planning, which is also a type of customer segmentation, but this looks more in detail in customer behaviors. For example, if somebody has watched a certain TV show, what other TV shows are they supposed to have they watched in past? And breaking this down further, the way this would work is that you have a TV show for which you have a bunch of watchers and non-watchers. So that will be a binary response variable. And you have 20,000 other TV shows. And for each of those TV shows, you have, say, 5 predictor variables. So you have one response variable and 20,000 cross 5 predictor variables. And as it turns out, the scale of our data is so huge, training a simple lasso model on that is very, very, very challenging. So that was one of the projects that one of my colleagues worked on. And for that, they actually had to write their own gradient descent based code in C++ to take care of this kind of problems and using an internal package of R. So these are the kind of challenges that we work on, which are even at the edge of big data work. So that's what makes things interesting. Even if you're not proposing a totally new machine learning method or totally new statistical method, this is still challenging in terms of how you implement it and how you can extract value from this large amount of data. We also work on AI-powered video and metadata, metadata, and also curating content, which means that looking for signals like faces, emotions, different types of objects in video content using deep learning models to extract these kind of contents from that video and to catalog those for future purposes. The fourth project is pretty interesting, which is keyword generation. And the reason being that in when you have data and the data has a number of variable names, which is suppose customer account key, something like that. That can be given as CUST underscore ACCT underscore key. And that CUST part, which means customer, that might not always be the same. Somebody can refer to as CUS, somebody can refer to as CUSTMR or something like that. So how do you know that all these three refer to the same thing? So this project, which another one of my colleagues worked on, this project was about using NLP-based methods to sort of find out those kind of mappings to simplify column names in large databases. The next project was also related to data quality and anomaly detection in data streams, which is also again related to database maintenance. So the reason that I am talking about all these different kinds of things is to sort of give an idea of a complexity that is typical to not only AT&T, but I think that would be typical to any large company that has lots of different types of data and lots of different volumes of data. So everybody in the industry has to deal with these type of huge scale. And these are some of the ways that people do it. And not only that, these are some of the up and coming ways. These are some of the cutting edge ways that people do it in the industry. And we also talk about, we are also working on a few methods that are related to fairness and transparency in machine learning. And not only that, we are talking about data privacy as well. For example, things like differential privacy. So these are also some of the methods, some of the areas that we are passionate in, we are involved into. There are a bunch of open source involvements that the labs is involved in. There is a lot of R development that is going on. And this person here, he is actually the co-president of the R Foundation. His name is Simon Urbanek. He used to be an AT&T employee until like just a month ago. So due to his legacy, there is a lot of development, open source development that is going on that is focused on R. We also have something called R Cloud, which is a collaborative development platform that can be used as a front end for R, Python, a console, everything else. Think like a Jupyter notebook, but for multi-platform. There's also something called nanocubes, which is like a large scale visualization platform for spatial temporal data sets. There is Ecumos, which is essentially a repository of built out models, an online repository of built out models that people can use or contribute to. So coming into a little bit of detail about what kind of work we do. The first point I already mentioned that there is a lot of data. And the way this is difficult, the reason this is difficult, the reason working with this is difficult is it requires an iterative process of not only the cleaning of the data, but the feature generation and modeling. And as I mentioned, any modeling has to be done in a scalable way. We have to make sure, just like any other industry company, that whatever we're doing is actually useful to the business. And the way we can get that use out of the data is not only to just throw the biggest and baddest and best models at the data, but to actually use domain knowledge, to actually use the knowledge about that specific data set to engineer features in a smart way such that you can make do with even simpler models. So this has happened to me multiple times, that after you generate features from the data, after you spend some time doing some exploratory analysis on the data, generate some features, you put some thought into generating the features, what happens is that the performance for complex models like random forest or gradient boosting, that's almost the same as a very simple lasso model. And in those kind of situations, even though the accuracy of the random forest model might be 1 or 2% higher, it might as well become more desirable that the lasso model is useful, because that takes a lot less time to train. And when new data comes in, that becomes a much easier option that can be updated. So these kind of considerations also go into an industry pipeline that we consider, and I'm sure that my peers in the industry will have faced similar problems and have come up with similar solutions. So these are some of the considerations that have to be taken. And not only that, not only this kind of methods are important and outcomes are important, it is also important how you present your outcomes. As statisticians, we are trained to be rigorous. We are trained to show the work we are doing, to show that, okay, we have done due diligence on these things. But depending on the client, depending on what audience you're presenting to, it is important to show them the value in the way they desire, which means that as output, one single table is good. As output, a table with 10 different numbers is good. But if you can show that instead of that table, if you can just show one single number that shows that here's the increase in accuracy compared to whatever model we are using right now, and here's the computational advantage as well, that becomes much more useful in driving home your point. And at the end of the day, that's what decides whether the project is going to be moved forward. So I think coming from an academic background, that's a very important lesson that I took in my last few years in this company. I think I now have 5 more minutes, so I'll just spend the rest of the time into a little bit of deep dive into one of the projects that I worked on. And that sort of also gives an idea into the presentation aspect of the whole thing, is that how you can present things in a small amount of time such that it is useful to people. Okay, so the goal of this project was to do content curation, essentially generation of highlights videos using AI and machine learning, using automated methods, basically, which also uses inputs from the viewers. So right now, some of you might know that there are deep learning approaches that look for signatures of interest in a specific video content, which is I'm talking about the left panel right now. So these signatures of interest can be, for a sports game, high audience noise. For something like Game of Thrones, this could be a dragon breathing fire, things like that. So deep learning models are applied on the whole video content to extract certain segments which are indicative of high interest, which are then curated either by a human or by a machine into highlights videos. So that's the state of the art right now. But the problem with this kind of approaches is that the interest cues they're looking for is not really generalizable. For example, high audience noise will not work for something like Game of Thrones, or dragon breathing fire will not work for sports games. So you'll have to come up with these kind of cues that are very specific to the content. Whereas something that is this content specific does not work for anything else. And the validation of the whole thing has to be done post hoc with something called something like Mechanical Turk, where you do a small user study and find out that whether this curated content is more interesting as compared to human curated highlights videos. So in place of that, what we did was we started off with viewership insights. We found out, we analyzed the whole timeline of a certain TV show, whole timeline of a certain content. We got viewership data anonymized from them for that content. We saw that across the timeline of the TV show, what specific segments were rewatched more by the viewers. That sort of gave us an idea that what segments are interesting. So we extracted those segments. We got a timeline for this viewer interest. We extracted those segments from that timeline using statistical anomaly detection methods. And then we fed those segments into the outputs that are coming from deep learning models. So we added those segments with different types of metadata outputs, for example, faces or dragons, or just like this, the first stage, just like the previous state-of-the-art high-interest cues. So you can actually combine these type of viewership insights to these metadata insights obtained from deep learning models to curate the segments. So this not only gives direct feedback from viewer insights to the curated segment, this actually gives you an option to personalize your outputs as well, because the metadata part contains things like faces and emotions. So based on what audience you're catering to, catering the highlights video to, you can actually supply different versions of the highlights video using these personalization signatures. So this was sort of a short overview. I hope this was not too unclear, and this was a well. And with that, I'd finish. I think my 20 minutes over. Thank you.
Thank you, Subho. We are a little bit behind the schedule, so I'll hand the time to Dr. Ted Listig. So Ted, you can get ready to present your slides. And Dr. Ted Listig is a Senior Director of Corporate Biostatistics at Medtronic.
Great.
It's yours, all yours.
Yep. So I'm going to focus not so much on data science as more traditional statistics, as it were, in this presentation. We certainly do have data scientists at Medtronic. I'll briefly allude to that. Probably one thing I'll quickly mention is, for us, like one of the main differentiators for when we're talking about the role of data scientists versus statisticians for us, is that the statisticians are ones that are really concerned with making conclusions, with drawing inference. And that's very much tied into a lot of the classical training we have as statisticians. And that's not to say that data scientists don't do that, but it's to say that that is a major focus area for statisticians. So that's, you know, one of the things how start thinking about what different roles involve in different situations. So I'm the Senior Director of Corporate Biostatistics. I lead biostatistics at Medtronic. And for what I'll be talking about briefly, I'll talk a little bit about our company at a glance. You may not be familiar with Medtronic, unlike, you know, perhaps AT&T is, Amazon, a little more familiar. I'll talk about getting a biostats job in industry, some of what we do at Medtronic, and a little bit of a closing. So for Medtronic, we're a medical device company, and we've been working since the late 40s. We were founded, and our main mission involves alleviate pain, restore health, and extend life. And what I'm showing here are founders on the right-hand side of the screen, and the co-founders on the left. And what they're showing is the doctor that has a battery-powered operated pacemaker that this young boy is using. So the pacemaker helps to control how your heart was beating. So a brief story why this is relevant. Before we had the battery-operated pacemakers, for very sick patients that might need help in pacing, often this might be prior to doing a heart transplant, you would use a pacemaker to allow the heart to beat regularly. When these patients were in the hospital, it would not be uncommon that you would have a patient treated on a certain floor of the hospital, but then they need to go on surgery on a different floor. And because these were not yet battery operated, you would actually have to plan to have a very long extension cord powering in the pacemaker, have that connected to the person while you wheel them on the gurney into the elevator. And then right before you close the elevator door, you unplug the pacemaker, have the elevator door close, elevator switches floors, elevator doors open, bring in the new extension cord, plug it in, get power back to the pacemaker to ensure that the heart is beating regularly. That's not something you want to have happen on a regular basis. And so we've gone a long way since then, from like cords, power cords going to pacemakers. And in fact, if you briefly look on the right-hand side, our founder is holding this small item that looks something in size like, say, a .22 bullet. And this is actually a fully implantable pacemaker that would go inside a heart and accomplishes much the same function as this big, bulky external item that was originally developed back in the 40s. So just one quick example of the type of work we do and how it's changed. We're broadly organized across multiple different business groups. We have a cardiac and vascular group. This would include things like pacemakers, defibrillators, stents. You might have heard about an older relative getting a stent put in. That would be within this group. We have a diabetes group that treats both type 1 and type 2 diabetics, persons that are insulin dependent or non-insulin dependent but still require some support. We have a minimally invasive therapies group that helps with, say, dialysis, various surgical innovations, bandages, staplers, that sort of thing. And restorative therapies group that includes everything from deep brain stimulation for Parkinson's disease, to various pain therapies, to specialty therapies, to spinal implants. If you hear about someone that had their spine fused, we make products that do that sort of thing. As a company, we have over 90,000 employees. You may not have heard of us, but we're quite large, with over 10,000 scientists and engineers and 1,600 people plus in clinical. And we spend over 2.3 billion R&D investments and run about 370 plus clinical trials. And we have over 4,300 patents. So again, it's a space you may not be aware of, but there's a lot going on. We operate across the globe. We have our operational headquarters in Minnesota. We have our corporate incorporation is in Ireland, but we also have Greater China, APAC, Europe, Middle East and Africa, and Americas. We work across 150 different countries. So that's the brief overview of us, just to give you guys a background. And these slides will be available. I know I'm going a little fast, but trying to keep up with time here. So if you wanted to get a job in the industry, one question would be, how would you prepare yourself now while you're in school? So I'd say consider getting an RA or an internship with an applied focus. This is a great low-risk way to test alternatives to academia. In school, you're going to be surrounded by people that excelled at academia, know what it takes to do so, but you might not have as much exposure to persons in industry. So here's a way to talk to and interact with people that have that more of the focus. Think about choosing some relevant classes, everything from design and medical studies, maybe pharmacoepidemiology, survival analysis, consulting. Also look for some opportunities to co-author applied publications. This might regularly happen as part of an RA, for example. Work on improving your presentation skills. And this might not necessarily be done within the department you're working in. You might want to work with the communications department to take a course in public speaking. Try to find opportunities to do multiple oral presentations. You'll end up doing this more than you might imagine. And then finally, it certainly does not hurt to get some form of programming certification. There's a lot of this available within SAS, and we're starting to see some examples now where instead of a formal certification, perhaps you're archiving your code, loading it up to GitHub where it's accessible and viewable by your potential employer. That's certainly a possible route to take as well. Another thing to think about is if you're going to get a job in industry, where do you want to live? So Minneapolis is, as it turns out, because we were one of the early medical device companies, we're a hotbed for the medical device industry here in the Midwest. If you're interested more in pharmaceutical companies, they are heavily clustered between Philadelphia and New York City area. but also extend up towards Boston and a fairly large presence in the Bay Area in San Francisco. Outside of those major areas, there can be somewhat limited prospects. So you would either be really committing to a company with a large campus, or you might be thinking more in terms of saying, well, does the company have multiple sites I can move between? And there are also international opportunities that exist for the adventurous. One thing to think about as well as you're looking to get a job in the industry, are you looking to join a big company or a small company? The larger companies tend to have multiple well-established career paths. The smaller companies might have more chances to try different roles. The larger companies as well tend to have need for specialists, so there's going to be more large companies going after your PhDs than the small ones, just in terms of scale. But the benefits and the financial security can vary sharply between these companies, high risk, high reward sort of scenario. Thing to keep in mind is that the hiring cycles at companies rarely align with academic calendars. I'm helping to identify a new chair for the Division of Biostatistics at the University of Minnesota. We're interviewing candidates now that would start next fall. Whereas on the industry side, we have short hiring windows. I might post a job on February 1st and look to have that filled by the end of the month. So that's a very different kind of time schedule. And those jobs can also change frequently for the postings. Do keep in mind that people tend to join companies but leave managers. So one of the things to consider as you go through your process of evaluating your future job prospects is ensuring that you've got some good interpersonal chemistry with the person that's going to at least start off to be your line manager. That will matter. If you're searching for companies, think about making a list of your target employers. So suppose you're looking at the biopharmaceutical industry. Create a list of the top 20 by revenue. And that's something that's broadly available. And you might choose to filter it based upon location. You either might be very keen to live in the New York City area, or maybe you want to live in California. But look at who's available in those places. And it might be a satellite campus of a company as opposed to headquarters. Go to the company websites to look for jobs. And then also look at places like LinkedIn or MStat.org or other job sites just to get a sense in terms of what's available and where it's at. Do try to network, find out what friends of friends think of working for the company so you're not just going in blind. Ask them to tell you maybe about either current or future job openings. Again, especially in industry, this happens so quickly that you want a way to find out about things that are coming online. Do consider asking a friend to arrange an informational interview with someone from the company, but please don't abuse this. I'm willing to talk to occasional persons, but I could spend all day talking with prospects. That would be a bit much. Recruiters will sometimes get in touch with you. This is more relative as you go into your career, because the role of the recruiter is to bring unknown applicants to employers. If you are just starting out, then the recruiters also get a sort of a percentage often on your salary. So it's more valuable for them to work with persons later in the career. Also, because they bring unknown applicants to employers, the recruiters aren't really interested in talking to you if you've already applied to the target company, because then they aren't introducing you. You are already known to the company. So, keep that in mind in terms of balance for applications versus recruiters if you get on that path. In terms of applying, make sure you prepare your CV or your resume carefully. Consider tailoring it to each job application. Show you meet the requirements. You can do a lot of this with a good cover letter. The situation here too is not talk about how you benefit from the job, but really how the company benefits from having you there. Are there particular skills or backgrounds that are a particularly good match for what the company has said it's looking for in its ad? Try to find some projects or accomplishments that'd be interesting to talk about more in an interview. You want to have it where there's enough information and materials you send for them to be interested, but not so much that they don't need to ask any questions. Do make sure that you have no spelling or grammar errors. Those will stand out, and it's an easy fix. Take the time to be careful, look things over, get a friend to help out. You would often apply through a company's web portal, especially if you're coming straight out of school. There might be other mechanisms as you go later through your career. When you're in the interviewing stage, make sure you're polite. Review publicly available information on the company, be informed. Any information you put on your application is fair game. Don't be surprised if someone asks you about something you haven't done in a while, if it's on your CV. They're gonna look at that, and for them it's new and it might be interesting. Be prepared to talk to it. When you do speak to it, think about ahead of time of preparing STAR segments. So have a situation, a task, an action you took, and a result. You want to be able to sort of have these pithy stories that you're sharing with the reviewer, so you know how to wrap things up and move from topic to topic. And finally, make sure you have a few questions for the interviewer. It's a little off-putting if you talk to someone, you know, you're asking all about them, ask if they have any questions for you, and they say, oh, not really. So are they not interested in your company? Did they not do their homework? What's the issue? So make sure you've got a couple questions for the interviewer. Compensation is something that comes up. And again, if you're thinking about small company versus large company, this is done in different ways. Because the compensation includes your base salary, includes your benefits, healthcare, bonus targets. There may or may not be relocation assistance available. Even if it is, it might be as a lump sum or as a service, but this will usually be specified in the job posting. If it's there, they'll tell you. For new professionals coming in, there's actually not a whole lot of negotiation. You'll have benefits that vary between the companies, but not a whole lot within a company. The bonus targets are usually fixed by job level, and the salary ranges tend to be a bit narrow. But going into this, be informed, you know, one of the advantages of being a statistician is that we like data, we share data. So the ASA on the AMSTAT website, see the link here, publishes a list of salary surveys. I'm showing one over here. This is came out in 2017. It's a little dated, it's the most recent one, but this is for non-academic employment. Now this is averaged across all levels of experience, but nonetheless, you can see, okay, what's some government examples, what's some for-profit industry examples, either pharmaceuticals, health and medicine, what have you. I think this is a good starting place. I don't know that's 100% accurate. I have a hard time believing that 10% of people that do general consulting for the federal government get over $700,000 a year. So again, starting place, but possible data quality issues. What about statisticians at Medtronic? Hans Rosling was not at Medtronic, but I just love his face. He's unfortunately deceased, but I'm just using him as a happy statistician here. So we have over 180 statisticians and statistical programmers at our company. This includes both biostatistics and industrial statistics. For us, industrial might be persons involved in manufacturing, quality, with various training issues, working on training our engineers, that sort of thing. Our major teams of statisticians are in that cardiac rhythm and heart failure, coronary and structural heart, neuromodulation, diabetes, and so on. Our main locations for statisticians include 3 different sites within the Minneapolis-St. Paul area, a pair of sites within the greater LA area, a site in Memphis, Tennessee, a site, Santa Rosa, about an hour north of San Francisco. We also have statisticians in Rome, we have some statisticians in the Netherlands, we have individual persons, other areas as well. But these are sort of like the main areas. When we're hiring, we have obviously a strong preference to have someone that is near other people in their group. But we do also have persons that, as they have gained experience in their career, have relocated to become remote workers. That's something that can exist. You think about titles. So we have individual contributor titles ranging from an associate statistician, all the way up in principal to an individual contributor that can be a vice president. There's also management titles, manager, senior manager, all the way up to a senior vice president. And if you look sort of in parallel, things in the same vertical level, so a principal statistician would be equivalent to a manager, senior principal to a senior manager, and so on. Briefly speaking, so a statistician might be something you could get with a good program coming out of an undergraduate. Senior statistician might be a master's degree with no experience. Principal statistician would be a PhD with no experience if they've got sort of good training background consulting. Beyond that, you're pretty much needing to have on-the-job experience to get to those higher titles. But the major differentiators going across here is not necessarily what tasks you do so much as what is your degree of autonomy, what is your degree of impact? How much supervision does someone need to give you? Do you identify and avoid problems ahead of time on your own, or do you need to have someone point them out to you? Are you able to impact not only your own work, but that of others? Well, that's obviously more valuable to the company, will later be rewarded with higher titles. So some of the common tasks we do, this involves developing a study, reviewing a study protocol, having objectives, hypotheses, and so on, monitoring the progress of the study, develop and review statistical analysis plans, much more detailed to the protocol, which includes statistical methods and explicit analysis data set specifications, analyzing data from clinical studies, prepare, interpret, present results, interact with regulatory agencies. One thing I was a little bit surprised with as I moved into the industry was how much time I spent working on documents, not just on coding or writing formulas, that sort of thing. Certainly those are activities where we spend a lot of time, but you also need to be good at communicating both orally and written. There's other things we do too. We participate in investigator meetings, educate field support staff. We develop or modify standard operating procedures, how we more effective as a function. Maybe we'll support FDA advisory panel meetings, which can be quite exciting, often in terms of generating data, but sometimes in terms of presenting. We did this last summer. We might negotiate proposed study designs with regulatory bodies, usually written, sometimes over the phone, occasionally in person. We'll present and discuss work internally, manage multifunction projects, and remain current on state-of-the-art statistical methods, and often extend existing methods to challenging applications. We do come up with new methods work, but that's not the point. The point is to get to an appropriate answer. If existing tools work, great. If you need to develop something, we'll do that as needed. So in total, just going up, our therapies at Medtronic, one of our big things is that we were able to say that we're able to improve the lives of more than 2 people every second, right? So we are a company, we're not unique, but not everyone is this way. It's highly mission driven. You know, for us, it's about the patient. What can we do to improve the lives of the patients? On top of that too, one of the things that I like to talk about is we have a very strong workplace, everything from being in the top 50 for diversity to being in the top 100 list for Thomson Reuters, best run company from Wall Street Journal, and then the LGBTQ Business Equality Excellence Awards. So we do strive to be an appropriate company that persons would choose to work at. Lots of people, even if you aren't familiar with them ahead of time, they come here to Minnesota, everyone knows about Medtronic, they're really impressed with it, it's a great company. And we are regularly hiring and looking to get good persons to join our team. So with that, our closing mantra, let's take healthcare further together. My email is here, and I'm certainly happy to follow up on further questions later on. So that's it.
Thank you, Ted. Just a reminder to the attendee, you can click the Q&A icon at the bottom of the Zoom window to ask questions. You don't need to wait until the very end. And our last speaker today is Bonnie Ghosh Dasdida. She's a senior statistician and head at RAND Statistics Groups. And I'll hand it over to you, Bonnie.
Yes, Sue, are you able to see my screen?
Yes, you want to make it, click on that and it'll be full screen. Okay, you're good. Good to go.
So thank you all for joining. I wanted to take a few minutes to talk about RAND and then speak to you specifically about the RAND Statistics Group. Remember, these slides will be on the NISS website. So RAND is a nonprofit organization that helps improve policy and decision-making through research and analysis. We are what's known as a think tank. We are a little bit unique in our setup as many think tanks are, and I'll mention a few things about RAND. So we are a nonprofit, unlike some of the other organizations discussed today. We are a global research institution. Our product is research and analysis. It's a unique collection of men and women focused on the critical issues of our time. Whatever is the current public policy crisis, that's what we'll be studying at RAND. It also offers a Center for Education and Training and Policy Analysis, which is the RAND Pardee Graduate School, where we train our PhDs in policy. And sometimes RAND is confusing to categorize. We are not a university, we are not management consulting, but we do have capabilities of both, I would say, and we do take on projects that seem very academic in nature and some projects that seem like management consulting. Currently, RAND is global. Since it started in the West Coast in Santa Monica, which is our headquarters, but we've expanded. And we do have now offices in Cambridge, Brussels, and Canberra. But Santa Monica, Pittsburgh, and Washington, DC are our biggest offices. I happen to live over in San Francisco. RAND's research agenda is broad. So even though you have a statistical background, once you come to RAND, that maps onto certain substantive areas you might be working in. For example, I work on health, healthcare, and aging, as well as education and literacy. But this kind of wheel gives you an idea of the range of topics, and the goal ultimately, or the mission, is to provide a practical solution to complex problems. RAND's key resource is its 1,200 research staff. We have about 54% that are PhDs, and this includes MDs and JDs. 10% are bachelors, and the remaining are masters. On the left, you see the disciplines, and there's a range of disciplines. We sit in the group that's statistics, mathematics, and OR, and we're about 7% of that research staff. This is just an example of some of the critical issues that we've published on lately. For example, we've done a roadmap for improving dementia long-term care. I highlight that because I've worked in that area. We also have some colleagues in the Bay Area that are working on self-driving vehicles and the policy implications around it, on autonomous vehicle technology. There's quite a bit of work in national security too, political scientists and national security. This slide I won't emphasize very much, but we do have a PhD school within RAND, the Pardee RAND Graduate School. It has about 100 students currently, and this combines cutting edge courses with on-the-job training. Our PhD students kind of get trained through RAND on working on also public policy applications. So I don't have a very long set of slides, so hopefully I stay on track so people can ask questions, keeping an eye on the time. Established in 1976, the RAND Statistics Group has a long history and legacy, I would say. So today we are 33 people strong. It started out primarily as a PhD focused group focused on research and modeling, but currently we are about 50-50 in terms of PhD and master's analysts. So statisticians are PhD level. So we have 16 of those, master's analysts are 16. We currently have a bachelor's research assistant, and we get a few summer associates every summer through our summer associate program. So one of the things I want to highlight is what are the skills needed for a PhD to succeed at RAND? So the assumption is you come out of a program with a solid, well-rounded education. But one thing that seems very important, even though you're working on public policy applications, is the ability to conduct statistical research, because many a time you'll find that for a really hard problem, it's hard to find a well-developed or a canned approach that fits that problem. So there is a need to be able to step in and do your own research. Depending on the range of topics you're working on, such as are you working on opioid use, gun policy research, are you working on environmental interventions on individual health like diabetes, the range of topics just means that you need to have quite a bit of breadth in technical expertise, and you also have to have depth. And sometimes you build it on the job, meaning maybe you do a big lit review, get a stack of papers and kind of find out the approaches that are most required for that. And if need be, you extend the current paradigm or current approach and do your own research, and that would be perfectly fine on a RAND project. One essential thing, it seems obvious, but worth saying, is you have to be interested in applied and public policy work. If your desire is to primarily do methodological research, RAND is probably not the place for you, because you have to be engaged in the substantive topic or area that you're working in. Otherwise, I don't think it's a good fit for you. Another really important aspect of work at RAND is, even though people come with a very solid technical background, it's not always clear how well developed is one's ability to write and communicate. Remember, you'll be speaking with people in other disciplines. We typically work as one of an interdisciplinary team, so it's very important to be able to write well, communicate well, and these communications can go all the way to the White House. I've been on one study which was commissioned by the White House. So you have to be able to take it all the way to people in the military, people at the highest levels of public policy. And you have to be able to get across your technical findings in the best language possible to convince a policymaker. We also encourage methodological as well as applied publications from our statistician. In addition, there's one skill that, that really helps somebody be successful at RAND, and that is this flexibility to work simultaneously across projects and topic areas at the same time. So just being able to juggle multiple topic areas and multiple projects is really important, I think, to success at RAND. The skills needed for a MS analyst position at RAND, some are similar, some are slightly different. I would say the master's level position, it's important to be able to design, implement statistical methods using multiple programming platforms. You do need an ability to learn and implement novel methods, but I would say the analysts are doing far more, say, implementation in their career. There is a need for strong communication. Again, you're part of an interdisciplinary team, and communication is what sort of gets you, conveys your message to the other people on the team. And this may include for the master's analyst, including use of graphical sort of visualization tables. You have to be able to get your results across to the entire team, not just to the statistician on the team. And flexibility to work across projects and topic areas at the same time are also important for success. In terms of career path for statisticians are an integral part of RAND projects. RAND as a think tank, its hallmark, I think, is quantitative analysis. So statisticians are really important. And as a result, they advance quickly. They get promoted very quickly across the levels. So for PhDs, it's associate, full, and senior. For masters, there are 5 levels. Depending on your experience you enter with, level 1 to level 5. We also have a distinguished chair in statistics currently held by Mark Elliott. There are also many management opportunities along the way. By that, what I mean is you can grow to be a project leader. You can become fully a substantive project leader. Like I lead some studies in obesity. I've led some studies in depression. We also have certain centers. For example, at RAND, we have a Center for Causal Inference. One of my colleagues, Beth Ann Griffin, in the picture here, she, for example, has several NIH National Institutes for Health funded grants on causal inference, and she has served as a co-director of the Center for Causal Inference. I wanted to offer a little bit general advice for statistics students, but I feel like a lot of this was covered in the talk before me. At least for RAND, I think it's important to get a well-rounded education. I cannot highlight enough the need for soft skills, writing, speaking, being able to convey your message to actually have impact in your work. I also suggest for fresh graduates, especially to gain experience, internships, interdisciplinary collaborations. If you want to do interdisciplinary work in the future, reach out to other departments in your university and seek those opportunities. Take time to evaluate an organization, read papers, attend talks at conferences, look at the websites, connect with professionals at that organization to learn a little bit more about the reality that's behind that advertisement. Overall, I would say grow your network. I found that to be really helpful even when I started looking for a job. For example, you might join an ASA section. The American Statistical Association has several sections. We are very well represented in health policy statistics. And if you come to their mixers, you end up meeting people that work in that field that interests you. Finally, I cannot say this enough, find a job that challenges you and find your passion. You'll be working more hours than you spend with your family or at home. So you really need to be passionate to ultimately have satisfaction and quality of life. Our current hiring cycle just closed. It'll open again in fall 2020. That said, we're always looking for exceptional candidates, but we just made a hire and we follow the academic recruiting cycle. We do offer internships. There's 1 to 2 statistics PhD students per summer that join our group. Here are some web links to resources. If you look on there, I'm listed. I have a biograph, but go to rand.org and look for statistics and jobs there to get an idea of the kinds of jobs we're posting. And lastly, any questions are welcome. Thank you, Yasu.
Thank you, Bonnie. And thank you for all 4 speakers today of introducing their organization and introducing statisticians in their organizations. And so now we come to the last section, Q&A section. The first, I have 2 questions. So I will read out the questions and you will feel free to address them. Could you give some advice about doing presentation in industry? Seems to be hard to catch the audience's interest. Any of you want to start?
So I'll mention, I actually wrote a response to this. With what I said is that you'll have some very varied audiences and you need to think about how to tailor your presentation, tailor your material for the different needs of those audiences. And that would depend. Maybe you're giving a technical talk to a technical group or a non-technical talk to a technical group or vice versa. One small thing that I try to do is just to have this mix of text and images on nearly every slide, because people process information differently, right? Don't give things that are just table after table after table. Don't just do graph after graph after graph. You know, give some anchors so the slides are self-sustaining, that you can understand it in isolation, but do try to have that sort of mixture of types of information that you're presenting.
One quick response is, in our job docs, we require that a candidate be able to demonstrate statistical chops. You need to have a technical part of it, but you also need to have an application that drives it. I happen to have one from the NHANES, the Health and Nutrition Examination Survey. And one really little piece of advice a colleague of mine gave to a job candidate this year: firstly, feel free to reach out. We are very accessible, all of us, for job advice if you're applying to our organization especially, but the advice was, if you lose, so there'll be two kinds of people, at least at RAND. There'll be, say, MDs or substantive experts if you're doing criminal justice or some topic, but there'll be lots of statisticians, more statisticians than others. But if you lose the others for more than, say, 7 minutes in your doc, then I think it's not successful. You need to be able to take your work and be able to digest and explain to somebody, why is that important? Why should they care? What is the novelty? What are you adding to the current literature? So if you're able to communicate that language to the person on the other end that's not a statistician, they will engage and they'll be interested. And you have to be able to move back and forth between methodology. You have to be able to prove you have novelty, you've contributed to statistics, but you also have to be able to show that it matters.
So one of the input I would like to add is, as you mentioned in the question, we have to put the interest of the audience first. So from a statistician point of view, we usually is actually, we are viewed as a gatekeeper. It's more like we always say, no, not enough sample and not significant. It is true based on the current status of your analysis, but if you only say no, and people is going to lose interest, because maybe they come to you for suggestions they already know is not working. And most importantly is actually we provide solutions, provide alternatives. Like let's say, for example, we found out the sample size is not large enough, and then we say not large enough is definitely not sufficient. We have to say we need to add 100 more sample. We have to kind of like provide alternative solution, because people come to statistician is for solutions, where they're not just want to listen to negative feedback. They want a positive, constructive solutions and guidance to have the project done.
All right. I have another question. Hello, what advice would you give to people that wants to do a change in their career, let's say from a business background to a more technical field? Where or how to start?
I'll actually punt that off to Bonnie, because Bonnie, I thought you had a really nice statement there about, you know, finding your passion. So it's one thing to state, I want to change my career, but it's better to have a sense, not just what you're leaving, but what do you want to go into? Because any kind of training is going to take time and effort, and it's got to be something that you're interested in spending the time in, and you're going to spend a lot more time in it when you're done. So I don't know, Bonnie, if you want to build on that a little bit.
So, you know, I was wondering if this person had in particular a leaning towards data science. I just wanted to mention, I forgot to say that data scientists at RAND are primarily right now in engineering and applied sciences. And we're having a discussion today on, we have some machine learning specialists in our group, whether we should become statistics and data science. So yeah, it is, I think, there are career counselors, there are professionals and maybe in your network that you could speak to about the types of job they do and what appeals to you. So that was the point about passion. But when you say technical, what I don't exactly know is, does it mean that what you need apart from a PhD in statistics? And perhaps Shubho or Ming would have something to add to that in terms of how to build your resume or portfolio.
I'm going to add, like, from a business to technical field, there are two major skills that need to kind of develop. The first one is background in statistical theory, in machine learning. The other is programming background. So to be a technical, we usually means have to be familiar with one of the scripting language, either R, Python, or SAS. At least one of those has to be good at it. So that's the two kind of requirement to become a technical field. But technical can be at different levels. So it really depends on what kind of technical level that we're talking about. In my slides, I mentioned all those actually in those data science career paths in Amazon. Those are actually technical career paths. They're designed for people with bachelor's degree in statistics, master's degree in statistics, as well as PhD degrees in statistics. So depending on the background as well as which area you would like to develop, it actually depends. The answer will depends. But ultimately, it's going to be one or both of those two areas, statistical and machine learning modeling background and the programming background.
And if I may add to both Ming and Bonnie, both of you, in terms of adding to the skill set, the opportunities that people can do it from when coming from a non-technical / business background is also based on the companies. There can be different opportunities. A lot of companies like AT&T also has internal resources. We allow people to take Udacity courses or nano degrees, as we call it, to sort of get machine learning expertise or data engineering expertise. So if somebody is interested in getting these kind of things based on the company, look into your company, see that what your company has available, take advantage of it, and also take advantage of external courses as well. If getting a formal degree is too difficult, which it might be because you're coming from a business background. So I think, yeah, picking up skills that way helps. And also, if what I believe in is there is no substitute to practical projects. So if you can also pick up the technical skills while working on a project inside the company, that is also very useful. So these are some of the ways that can be utilized based on what background, what company you're in, or what your own position in, to pick up those technical skills to move forward.
All right. With that, I hope that some of you can go through the last question, another question on Q&A that you can type your answer because time is running up. I think we can wrap up the meeting today. Thank you all for attending.